Hello, we're going to take a look at mains electricity again in this video, the second video on mains electricity, but we're going to focus on the idea of a fuse and the earth wire as safety devices for when we use appliances connected to the mains. Okay, so here's our plug. We've got the fuse, the live wire. Let's just label those in. That's the fuse on the right hand side. That's connected to our live wire. And then in blue on the left, we have our neutral wire, as we've discussed in our last video. And then in the middle there, we have the earth wire, which is, the color is green and yellow stripes. Okay, so we've covered that before. But in terms of our toaster, we can see that we have the live wire connected via the heating element to the neutral. And that gives us a potential difference of 230 volts. And that allows us to have some toast, allows the toaster to work. Now, one key thing about toasters, and in fact a few other appliances like kettles or washing machines and fridges, is that the case is often made of metal. So this toaster has a metal case, and if for some reason the live wire, which supplies potential difference, for some reason gets connected to the case, that means that metal case is now live. So the metal case is now live, and that's quite dangerous, because if a person was to come along and touch that metal case, that means they would connect that metal case, the live case, to the ground, or in other words to the earth, and we would have a potential difference between the person and the earth, and that would cause an electric shock. You'll remember that we said we described the earth as being at 0 volts, and the live would then be at 230 volts. So there'd be a potential difference of 230 volts across the person, and that would cause our electric shock. Now, fortunately, the toaster is designed so that doesn't happen. We have our earth wire over here, and that earth wire is permanently connected to the metal casing. The toaster is built so that the earth wire is connected to the metal casing. Now what that means is that if our live wire did for any reason come into contact with our metal case over here, we would then get a current flowing from the live wire through the earth wire back to earth. So there would be a potential difference between the live wire and the earth wire of 230 volts. That would mean that there would be a current flowing through the earth wire. It tends to be a high current because the resistance is quite low, and that means the fuse will have a high current going through it, and the fuse will blow. The fuse blows, and when the fuse blows, that means the circuit is broken and no more current flows, and it is safe. Now, technically the fuse melts, but we can describe it as the fuse blowing to break that circuit. If we were to then note down how to make a note, or how to write this down, we would say that if the case becomes live, the current flows from live to earth, causing the fuse to melt. The fuse gets hot and it melts and breaks the circuit. So those are the kind of bullet points that you would make a note of or write down if you're explaining this. And this might be a 2 or 3 mark question, but if there were more marks, you would have to describe how the fact that we have 230 volts potential difference between the earth wire and the fuse, because they have now come into contact with each other. Okay, and I would actually use the word melt rather than the word blow. I think you can use the word blow in the spec, and you will get marks for it, but I would just stick to melt just to be safe, because technically that's what happens. Okay, so how a fuse and an earth wire are useful in terms of safety for appliances with metal cases.